have that a car of mass 1400 kg is moving along a straight horizontal road against a resistance of magnitude 350 newtons. A. Find in kilowatts the rate at which the engine of the car is working when it is traveling at a constant speed of 20 meters per second. So first let's draw a diagram. So this is the straight horizontal road. Let's say this is the car. It has a mass of 1400, so its weight will be 14,000. And then they're saying that the car is moving along, so the engine of the car is exerting a certain driving force with its power. So there will be a driving force, also known as a forward, and they have told us that there is a resistance of magnitude 350 newtons, which is basically friction 350, and it will act, let's say in this case, leftwards since the car is moving rightwards. And other than that, they have given us the speed at which it is traveling, which is constant, of 20 meters. So the key word in this question is the rate at which the engine of the car is working, which is just a fancy way of saying power, and in this case instantaneous power, and its formula is always equals to the driving force multiplied by the velocity. So we have the velocity, which is 20, but we need to find out the driving force in order to find the power. We can find out the driving force using the forces formula, which is forward force minus resistive force is equals to mass multiplied by acceleration. Why this works is that the forward force in this case is also the driving force. So we will write this as the driving force. There is a resistive force of 350 newtons, which is a friction. And then since the car is moving at a constant speed, the acceleration will be 0. So the right side of the equation will become 0, making the driving force equals to 350. Now we have both the driving force as well as the velocity, and we can insert it into this power formula to find out the rate at which the engine is working. So power will be equals to 350 multiplied by 20, and that is equals to 7,000 watts. Now they asked us to give us the answer in kilowatts, so we will divide it by 1000. So that means the power of the engine is 7 kilowatts. For part B, they're saying that find the acceleration of the car when its speed is 20 meters per second and the engine is working at 15 kilowatts. So what they've given us is the power again, which is equals to 15,000 watts, and its speed is 20. Now note, they have told us that this is not the constant speed, so in this case there will be acceleration. In order to find the acceleration of the car, we will need to use the forces formula, which is this, as we know. But for that we will require the forward force. So if you look closely, you will see that we can find out the forward force or the driving force using this information that we have. So power, which is 15,000, is equals to the driving force multiplied by velocity, which in this case is 20. Dividing 20 on both, we get that the driving force is equals to 750. Other than that, the friction will remain the same, which was given to us as 350, as given in the prompt of the question. 750, the driving force minus resistive force of 350, is equal to the mass 1400 times A. This becomes 400 is equals to 1400 times acceleration. Simplify this, acceleration is equals to 400 divided by 14. So this is 400 over 1400. Simplifying this 2 zeros cancel out, leaving 4 over 14. Simplifying it further, we get 2 over 7.